A planet unlike anything we expected has just been discovered, and it is rewriting everything scientists thought they knew about how worlds are born in the universe. Imagine a planet so enormous that it is 33 times larger than Earth, a true cosmic giant that defies the rules written in textbooks for decades. When researchers working with NASA first detected signals hinting at this strange world, they could hardly believe the data in front of them. At first, it seemed like a mistake, a glitch in the instruments, or perhaps a miscalculation in distance or size. But as more observations poured in, especially from the incredibly advanced James Webb Space Telescope, the truth became impossible to ignore. This was real, a massive, mysterious planet orbiting its star in a way that challenges everything we thought we understood about planetary formation. Scientists have long believed that planets form from disks of gas and dust surrounding young stars, slowly clumping together over millions of years. According to these models, there are limits to how large a planet can grow before it either becomes a star itself or is torn apart by gravitational forces. Yet this newly discovered world seems to sit right on the edge of those limits, raising an unsettling question. How did it get there? Was it formed in the traditional way? Or is there an entirely different process at work that we have yet to fully understand? The discovery did not happen overnight. It began with faint signals, slight dips in starlight that hinted at something passing in front of a distant star. These tiny changes, almost invisible at first glance, were carefully analyzed by astronomers who specialize in detecting exoplanets, worlds that exist far beyond our solar system. As the data became clearer, the size of the object causing these dips appeared far too large to be ordinary. This was no small rocky planet like Earth, nor even a typical gas giant like Jupiter. Instead, it was something far more extreme, something that exists at the very boundaries of planetary science. What makes this discovery even more fascinating is not just the size of the planet, but its strange orbit and unusual characteristics. Unlike planets in our solar system, which follow relatively stable and predictable paths, this giant world seems to behave differently, hinting at a chaotic past filled with powerful gravitational interactions. Some scientists believe it may have formed far from its star and later migrated inward, while others suggest it could be the result of a failed star formation process, a kind of in-between object that blurs the line between planets and stars. As researchers continue to study this mysterious giant, they are uncovering clues that could reshape our understanding of the cosmos itself. This is not just another discovery. It is a reminder that the universe is far more complex, unpredictable, and fascinating than we ever imagined, and we are only just beginning to uncover its secrets. As scientists continued to analyze this extraordinary world, the deeper they looked, the stranger it became. The planet's immense size alone was enough to spark intense debate, but its density, composition, and orbital behavior added even more layers of mystery. Using advanced instruments aboard the James Webb Space Telescope, researchers were able to examine the faint light passing through the planet's atmosphere as it moved across its star. This technique, known as spectroscopy, revealed hints of gases and thermal patterns that did not quite match what scientists would expect from a planet of this scale. Instead of fitting neatly into the category of a gas giant like Jupiter or Saturn, this object seemed to exist in a grey area, raising the possibility that it could be something entirely new. Meanwhile, teams working with data from NASA began running simulations to understand how such a massive planet could form. Traditional models suggest that once a growing planet reaches a certain size, it begins to rapidly accumulate gas from the surrounding disk, eventually becoming a gas giant. However, there are limits to this growth, and this planet appears to push far beyond them. One theory suggests that it may have formed in a region of space with an unusually dense concentration of material, allowing it to gather mass at a much faster rate than normal. Another possibility is that it formed through a process more similar to star formation, where a clump of gas collapses under its own gravity, but never gains enough mass to ignite nuclear fusion. If that is the case, then this world might be what scientists call a sub-brown dwarf, an object that sits somewhere between a planet and a star. Adding to the mystery is the planet's orbit, which does not behave the way scientists would expect. Instead of following a simple, circular path, it appears to move in a more elongated orbit, bringing it closer to its star at some points and much farther away at others. This kind of motion suggests a turbulent history, possibly involving close encounters with other massive objects that altered its trajectory over time. Some researchers believe that gravitational interactions with neighboring planets or even passing stars could have played a role in shaping its current orbit. Others suggest that the planet may have migrated from its original position, moving through the system like a wandering giant before settling into its present path. What makes all of this even more intriguing is that each new piece of data seems to raise more questions than answers. The planet challenges the very framework scientists use to classify celestial objects, forcing them to reconsider the boundaries between planets, brown dwarfs, and stars. As more observations are collected and new models are developed, this mysterious giant is becoming a focal point for researchers around the world. It is not just an object of curiosity. It is a puzzle that could unlock deeper insights into how the universe builds its most extreme and unusual worlds. Just when scientists thought they were beginning to understand this massive world, new findings introduced an even deeper layer of uncertainty and suspense. The data coming in from the James Webb Space Telescope began to reveal subtle fluctuations in temperature across the planet's atmosphere, suggesting powerful storms and extreme weather, unlike anything seen in our own solar system. These variations hinted at violent winds moving at incredible speeds, redistributing heat in ways that challenge existing atmospheric models. At the same time, faint chemical signatures pointed to complex compounds forming under intense pressure and heat, raising questions about what kind of environment truly exists on this distant giant. Scientists working with NASA started to realize that this was not just a simple case of a large planet, but rather a dynamic and possibly unstable world that could be evolving even now. What made the situation even more suspenseful was the possibility that this planet might not be alone. Some irregularities in the star's light suggested there could be additional objects in the same system, perhaps smaller planets or even another massive companion influencing its motion. If true, this would mean the system is far more complex than initially believed, with gravitational forces constantly pulling and shifting these celestial bodies over time. This raised a dramatic question that kept astronomers awake at night. Could this giant planet have formed through collisions or mergers with other planetary bodies? Such a scenario would explain its unusual mass and strange orbit, but it would also imply a violent past filled with catastrophic events. Imagine entire planets crashing together, combining their mass to create something far larger and more powerful than either one alone. While this idea may sound extreme, it is not impossible in the chaotic environments of young star systems. Adding to the mystery, researchers noticed slight inconsistencies in the planet's brightness over time. These changes could be caused by massive cloud formations, swirling storms, or even unknown processes that scientists have yet to identify. Each possibility opens the door to new theories, some of which challenge the very definitions used in planetary science. As the investigation deepened, the scientific community found itself divided. Some experts argued that this object should no longer be classified as a planet at all, suggesting it might be closer to a failed star, while others insisted that its characteristics still fit within an expanded definition of a planet. This debate is not just about labels. It reflects a deeper struggle to understand where the boundaries truly lie in the universe. As more data continues to arrive, the tension only grows, because every answer seems to lead to even more complex questions. This mysterious giant is no longer just a discovery. It has become a scientific enigma, one that is forcing humanity to rethink its place in a universe that is far more unpredictable and astonishing than anyone ever imagined. As researchers pushed further into the data, they began to compare this enormous world with other known exoplanets, hoping to find patterns or similarities that could explain its existence. Over the past few decades, thousands of exoplanets have been discovered, ranging from rocky Earth-like worlds to massive gas giants far larger than Jupiter. Yet none of them seem to match the extreme characteristics of this newly found giant. Using observations gathered through missions led by NASA, scientists built detailed models to simulate different formation scenarios, testing everything from rapid gas accumulation to gravitational collapse. Each simulation provided partial answers, but none could fully account for the planet's enormous size, unusual density, and unpredictable orbit all at once. This mismatch between theory and observation began to reveal a critical truth. Our current understanding of planetary formation might be incomplete. Meanwhile, data from the James Webb Space Telescope offered deeper insights into the planet's atmospheric structure. By analyzing infrared light, scientists could estimate temperature layers, chemical composition, and even the presence of clouds or storms. What they found was both fascinating and unsettling. The atmosphere appeared to contain elements and thermal patterns that did not align with standard expectations, suggesting that unknown processes might be shaping its evolution. Some researchers proposed that intense radiation from its parent star could be driving chemical reactions at a scale never seen before, while others suggested that internal heat generated by the planet itself might be influencing its atmosphere in unusual ways. These findings hinted that the planet is not just massive, but also incredibly active, with ongoing processes that continue to shape its structure. Another key question that emerged was whether this giant world could host moons or a surrounding disk of material. In our solar system, large planets like Jupiter are accompanied by dozens of moons, each with its own unique characteristics. If this planet follows a similar pattern, it could potentially have an entire system of smaller worlds orbiting around it. Detecting such moons from such vast distances is extremely challenging, but scientists are already developing new techniques to search for subtle signals that might reveal their presence. If discovered, these moons could provide valuable clues about the planet's formation history and the conditions within its system. As the investigation continued, it became clear that this discovery is more than just a single unusual planet. It is a gateway to understanding extreme environments across the universe. Every new detail adds to a growing body of evidence that the cosmos is filled with worlds far stranger and more diverse than we once believed. This realization is both exciting and humbling, reminding us that even with our most advanced technology, we have only begun to scratch the surface of what lies beyond our solar system. As the scientific community continued to debate and investigate, a larger realization began to take shape, one that extended far beyond this single mysterious world. This discovery was not just about one unusually massive planet, but about redefining the limits of what planets can be. For decades, astronomers have relied on classification systems that neatly separate planets, brown dwarfs, and stars based on mass, composition, and behavior. However, this giant object refuses to fit comfortably into any one category, forcing experts to reconsider whether these boundaries are as clear as once believed. Researchers collaborating with NASA have started to explore the idea that there may be entire classes of celestial objects that have yet to be properly defined, hidden in the vastness of space and waiting to be discovered. This planet could be one of the first clear examples of such an in-between category, a type of world that challenges the very language scientists use to describe the universe. At the same time, ongoing observations from the James Webb Space Telescope are continuing to reveal new layers of complexity. Subtle changes in the planet's emitted heat suggest that its internal structure may be far more dynamic than expected, possibly involving layers of gas, liquid, and exotic materials interacting under extreme pressure. These conditions could create energy flows and atmospheric behaviors unlike anything seen in our solar system, turning this planet into a natural laboratory for studying physics under extreme conditions. Such insights are incredibly valuable, as they help scientists test theories that cannot be replicated on Earth. Another important implication of this discovery lies in how it influences the search for other worlds. If such massive and unusual planets can exist, then it is possible that many more are out there, hidden in distant star systems and waiting to be detected. This has encouraged astronomers to refine their search methods, focusing not only on Earth-like planets, but also on extreme worlds that push the boundaries of current models. The discovery is already inspiring new missions, new technologies, and new ways of thinking about the universe. It is also reshaping how scientists interpret data from previously discovered exoplanets, as some of them may share characteristics that were overlooked or misunderstood in the past. Beyond the scientific implications, there is something profoundly inspiring about this finding. It reminds us that the universe is not limited by our expectations or our theories. No matter how advanced our knowledge becomes, there will always be discoveries that surprise us, challenge us, and push us to think in new ways. This giant planet stands as a powerful symbol of that truth, a reminder that we are explorers in a vast and ever-changing cosmos. As research continues and new data emerges, one thing is certain. This is only the beginning of a much larger story, one that will continue to unfold as humanity reaches further into the depths of space and uncovers the secrets that lie beyond. In the end, this extraordinary discovery leaves us standing at the edge of a new frontier in space exploration, where certainty begins to fade and curiosity takes over. What started as a faint signal in distant starlight has now grown into one of the most fascinating mysteries in modern astronomy. A planet so vishal and unusual that it challenges the very foundation of what we thought we understood about the universe. Through the relentless efforts of scientists working with NASA and the groundbreaking observations made possible by the James Webb Space Telescope, we are witnessing a moment where science is being pushed beyond its limits. This giant world is not just another addition to the growing list of exoplanets. It is a turning point, a discovery that forces us to ask deeper questions about how planets form, evolve, and survive in the extreme environments of space. Its immense size, unusual orbit, and mysterious characteristics serve as a powerful reminder that the universe is far more diverse than we once imagined. As we look to the future, researchers are already planning more detailed observations, hoping to uncover new clues about this planet's origin and behavior. With each new piece of data, we move one step closer to understanding not only this single world, but the broader processes that shape countless others across the cosmos. At the same time, this discovery is inspiring a new generation of scientists, thinkers, and explorers who will carry forward the quest to understand the universe. It shows us that even in an age of advanced technology, there are still mysteries waiting to be uncovered, still questions without answers, and still wonders beyond our reach. This sense of the unknown is what drives science forward, pushing humanity to explore deeper and think bigger. As we continue to search the skies, we may find even more extreme worlds, planets that challenge our imagination and expand our understanding of what is possible. And perhaps one day, discoveries like this will help us answer some of the biggest questions of all. How common are such extreme planets? What role do they play in the formation of star systems? And what can they teach us about our own place in the universe? Until then, this massive and mysterious planet remains a symbol of discovery, curiosity, and the endless possibilities that lie beyond our world. If you are benefiting from our topics, please subscribe, like, and turn on the bell notification so you can see our new videos early.